All right, we reviewed a lot of functions in our last lesson. We did even polynomials and odd polynomials. We did rational functions like 1 over x. We did v's for absolute value. And we did the square root and cube root equations. Well, any of those equations can be written in a piecewise function. So a piecewise function is when the function is defined by 2 or more formulas. So let's look at an example of what it looks like. So if we said function, this is f of x, is equal to 2 different pieces. One piece is going to be a line, negative 2x minus 2, and that's for values if x is less than or equal to -1, and if it's bigger than -1, it's going to be a parabola or x squared. So the function has 2 pieces in it. So it's like the XY chart is split into 2. Right? So what does that mean? That means that if we were, and I've kind of given you notes on the other side, on the left side, if you break apart the graph into 2 or 3 sections for each graph, you'll be able to graph it in sections. So let's see what I mean there. This graph breaks up at -1. So I'm going to kind of divide this here. And on the left side, where I've got numbers less than -1, I'm going to graph -2x minus 2. And when x is bigger than -1, I'm going to graph x squared. So it's broken up into 2 different sections. So this is the domain for the line, and greater than 1 is the domain for x squared. So here's what I mean. If I make an XY chart for -2x minus 2, those are the things that I'm going to graph on this side, because these are values where x is less than or equal to -1. And on this side, x is greater than -1, I'm going to graph x squared over here. That's a y. So piecewise, I'm going to graph a piece and then the other piece, 2 pieces. So let's look at this line, okay, because it's not going to go through. I'm not going to graph y equals mx plus b. This doesn't cross the y-axis, so I don't have that value to plug in. So what I want to do is put in values that include -1 and then move to the left. So I'm going to include this value, this value, this value, and this value. At -1, I'm going to include a closed dot because it includes -1 on this side of my graph. So let's see. If we put -1 into this equation, we have -2, -1 minus 2. So I'm taking this equation and I'm plugging in -1. -2 times -1 is +2, minus 2 is 0. 0. So at -1, I have a point at 0. And now I'm going to plug in -2. -2 times -2 minus 2. That's 4 minus 2 is +2. -2 up 2 is here. At -3, I've got -2 times -3 minus 2. That's 6 minus 2 is 4. So -3 is up 4. And I can see my line now. I'm going to go ahead and graph that line. But I'm not graphing the line that continues everywhere in this direction because I'm not allowed to. This line is only valid for x values that are less than -1, like -2 or 3 or even -4, which would be 6. So I graphed one piece. Now I'm going to graph the other piece. I'm going to graph x squared. So over here in my XY chart for x squared, I'm going to plug in values that are greater than -1, but I have to include things on the line. I'm going to include -1 even though it's not in the chart, but I'm going to put an open circle there, and I'm going to make myself a note. And I did so in your comments on the left. You can see that I've got, if it doesn't have an equals, it's an open dot, and if it does have an equals, it's a closed dot. So that's what I'm going to do here, is graph this point but with an open dot. So when I plug -1 into this equation, -1 squared is +1, and that value, -1, +1, I'm going to put an open circle. I'm going to plug in values bigger than -1, so I'm going to go -1, 0, 1, 2, 3, 0, 1, 2, that's enough. And I'm plugging them all into here. So I've got 0 squared is 0, 1 squared is 1, 2 squared is 4, and I'll plot those points. So 0, 0, 1, 1, 2, 4. So I have this like half a parabola there. This line and this line don't meet. They don't have to meet. I have two separate pieces and they don't have to meet. But this passes the vertical line test and it's still a function. So I can't call it a function unless it passes the vertical line test. And this does, because if I draw this blue line again through there, I only cross through this one dot. I pass through the circle. So it only crosses once. But by having the circle here, I'm including the values. I'm including all the values between -1 and 0. I can't just start at 0 in my chart. I need this part of my graph because I'm saying that x is greater than -1. That means that -1/2 is okay and -0.01 is okay and -0.9 is okay. I need this part of the graph, but I'm going to end it with an open circle. So in your piecewise functions, one piece will have a closed circle and one piece will have an open circle at the same x value. That's how you make it still be a function. Okay, so let's try this one. I'm going to help you set it up, talk about it a little bit, and then I want you to draw your xy axis. I want you to draw this in 3 separate pieces. So there is a constant, which is a straight line. This is like y equals 3. So a straight line would cross the y-axis, but doesn't because it's not in that domain. This is a line because it has an exponent of 1, so it's linear. This is a square root function, so we're only going to plug in squares to be able to graph points here. So the idea is that we have one, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 1, 2, 3, 4. Is that we have this grid. We have 3 separate pieces of this, and so I want you to separate your 3 pieces, pause the video, do the 3 pieces, and then you're going to want to graph each one in the section that it's in. So pause and write out each equation with an XY chart and separate your graph into a line at -2 and at 4. So you have 1, 2, 3 pieces. 1, 2, 3 pieces. And then graph each piece. And then see what you have. So pause the video and then come back. Okay, I've got 3 pieces. One is going to be at -2. And the other one's at 4. So I'm going to do it like I did last time. And I'm going to draw an imaginary line here that tells me my different pieces. That one did not quite go where I wanted it to go. That didn't erase like I wanted it to either. Here we go, there. Okay, So I've got 3 different pieces. This one is pretty easy to graph. It has an open circle because it doesn't have equals. So it's like a horizontal line, and no matter what x value I put in, if I say y equals 3, that means that y equals 3 for any x value that I put in. -2 is the value right here, which is going to have an open circle. -3, -4, -5, they're all going to be y value 3. So this is called the constant function because it's constant. -2 is at 3, an open circle. -3 is 3, 4 is 3. It looks like a straight line going this way. This is that piece. In the middle, I have a line with slope, and it crosses, it has a y-intercept of -4. So that means when I graph its piece, I'm going to write y equals 2x minus 4 and do an xy chart. My endpoints are -2 and 4. I'm going to put them in here. -2, and I'll put in 0, and I'll put in 4. I'll be able to connect those lines. So at -2, 2 times -2 is -4. That's going to be -8. At 0, I'm at -4. At +4, I'm at 4. So let's see. At -2, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. I'm here with a solid dot. This is a solid dot, open dot. Solid dot, open dot. Solid dot at -2 because the equals, open dot at 4. So I've got the solid dot there. 0, -4 is a point. 1, 2, 3, 4. And then 4, 4 up here with an open circle. Okay, so I have a line in the middle, and note that I haven't messed up the function. When I draw a vertical line, it only crosses here, and this one only doesn't cross anywhere yet. So let's see. My third equation is going to be y equals the square root of x, and it's going to have a solid dot at 4. So in my xy chart, I'm going to start at 4 like it says to, and then I'm going to go bigger, 5, 6, and then I'm going to go to 9. So at 4, I say the square root of 4 is 2. That's a point. 1, 2, 3, 4. 2 is a point. 5, the square root of 5, I'm not sure what that is, but it's bigger. I do know this one, the square root of 9 is 3. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it 3? It kind of goes like that. So there's my piecewise function. Horizontal line, line with slope 2, and then a piece of the square root curve. So you simply take each one of these, make its own graph. They can have their own XY chart. And then you have an open circle and a closed circle at all of these endpoints. So even though 4 is repeated, one of them is an open circle and one of them is a closed circle. So give those problems for practice a shot, and then we'll talk about them when we go over them in the next class. Okay, thanks.